In our last video, we had a look at analytical geometry and all the formulas that we'll find on the formula sheet. And we did a couple of examples, so if you missed that one, please go back and watch it. But having a look at how we incorporate the distance formula, the midpoint formula, there are two different options here for the gradient, either to calculate it or to determine the angle of inclination. Then you can work out the angle of a straight line, which we're going to focus on today, but we're going to apply that a little bit, different kinds of straight lines. And then a brand new one, the equation of the circle, where we saw that A and B were the coordinates of the center, and R is the length of the radius. So those are all the formulae that we need to know when we step into, or we need to know how to use them, because we do get them on the formula sheet, but we need to know how to use them when we step into our final exams. Now let's have a look at some of the ways they like to ask these questions, okay, because it's one thing to know the formulae and to know how to apply them in a straightforward question, but we need to be able to apply this knowledge. So if you look at this example, it says consider the circles below and determine whether they intersect in 2 points, touch externally at 1 point, or do not intersect at all. So basically we've got three scenarios here. We've either got two circles that will intersect at 2 points, so they'll intersect in more than one spot, or we've got two circles and they are literally just going to touch one another at 1 point, so one intersection there, or they're going to be so far apart that they're not going to touch at all. Okay, and the way that we need to work and approach this is by looking at the formula. Okay, so if we look at the first circle here, we can see that the center there is going to be 3 and 1, because we're going to take those coordinates there, and then the radius is simply the square root of 8. Okay, because it's A, B, and R squared on that side. All right, so if we look at our first circle, whatever it may be, we will definitely have, let's even try and sketch something here in place so that we know what we're dealing with. Okay, so on our Cartesian plane, we will have a center of 3 and 1, so that'll be around about here, and a radius of the square root of 8, which is going to be just less than 3. If I think square root of 9 would be 3. So we'll have a circle, probably something that looks a little bit like that. Okay, doesn't have to be accurate. This is really just for us to try and logically understand how to answer this. Okay, now they want us, well, let's even pop in the radius there, root of 8. Okay, now they want us to know if they introduce another circle here. But this circle requires some work. We don't know yet what the center is, what the radius is. We are going to have to do that thing that we learned in the previous video where we complete the square. Okay, so let's get ready to do that. So the first thing I do is I'll take this 2 across because I want to have x's together, y's together, and then my minus 2 over there on the other side, the constant term, which is going to help us get the radius or the length of the radius. Okay, so now what we do is we want to complete the square. So we'll say we're going to have 2 brackets here equals minus 2. Okay, x times x gives me x squared. Y times y gives me y squared. And then what we did each time was we took half of the coefficient of b. I'm calling it b in each case. Okay, so half of 4 is going to be plus 2, and half of 8 is going to be plus 4. But then, if you remember correctly, when we multiply this out, when we distribute everything, we ended up with an extra plus 4. This last term gets squared. So what I do to the one side, I have to do to the other side. So I need to add an extra plus 4 there, because it was 2 times 2. And then over here, an extra 4 times 4. So an extra plus 16. Okay, that is tight over there, but I think you're getting what we're saying. So x plus 2 squared plus y plus 4 squared equals minus 2 plus 4 plus 16 gives us 18 there. Okay, and that's helpful because now I can picture my next circle where I have a center, let's call it M for midpoint because we already used C for the other circle. Okay, the midpoint here is minus 2 minus 4, and the radius is the square root of 18. Okay, so if I were to picture this somewhere, square root of 18, although 18 is bigger than 16, which is an answer of 4, so it's going to be a bit bigger than 4, and I could plot it minus 2 minus 4, probably with a center down here somewhere, and then maybe here. Okay, so it seems like these two will intersect, but this is not going to be mathematical enough. My teacher is definitely not going to be happy with this as my answer. I'm going to need to do some calculations. Okay, I just always think it's wise to draw a sketch because it guides me along the way. Okay, so what I want to do now is I want to figure out, in terms of these radii, if I could link them, then that would help me to discover either they overlap or they don't touch at all. So what I think we should do is we should work out the distance here between these two centers. And if it's longer than the two radii added together, then we know the circles don't touch. And if it's exactly equal, then we know the circles will touch in just one place. And if this distance here is smaller than radius 1 plus radius 2, then they definitely intersect. Okay, so we've got two radii. That's good. We are part of the way there. Let's get the distance then of, I've called these points C and M. So the distance of MC is equal to, and then you can consult the formula on your formula sheets if you need it, but basically it's going to be x1 minus x2, so 3 minus 2 squared, plus y1 minus y2, 1 minus 4, so 1, a minus is a plus. There we go. Okay, so the distance now is going to be 3 plus 2 squared plus 1 plus 4 squared. So we end up there with the root of 50. Okay, and let's get that into a decimal form. So the root of 50 will give us 7,07. 7,07. Okay, so that's the distance between the two centers. Now let's figure out what's happening in terms of the radii. Okay, so radius of the big circle plus, let's do that, radius of the small circle, we'll even call this one big R, that'll help us, is going to be root of 8 plus root of 18. I actually think we would have been better off calling the second one the big circle, but that's not super important. Let's calculate now. We've got the root of 18 plus the root of 8, and we end up with, oh, my drawing very off, 7,07. So what's happened here is that they are telling me that if I had plotted these circles accurately, and this is why I say it's so important to calculate, we would have seen something like this. We would have seen two circles, one which would be somewhere around about here, let's say, and the other one which would happen somewhere here, and the length of the radius of this one plus the length of the radius of this one is exactly equal to 7,07, the distance between the 2 points. And so therefore we can conclude they touch externally, or just at one place. Okay, so just to answer their question. So if ever you get asked this question, and it is quite a common question, which is why I've opted to use it here, but you need to work out the distance between the two centers, and then you need to compare. If it's shorter than the two radii, then you know they intersect. If it's exactly equal like this, then they touch at only one point. And if it's completely different, then you know they don't touch at all. Okay. Now, before we move into the next application question, let's quickly refresh our knowledge here. A line that touches a circle at only one spot is called a tangent. And remember, please, from your grade 11 geometry, that the tangent is perpendicular to a radius at that point. Okay. Then we've got a line inside the circle that goes from circumference to circumference. That's called a chord. A line that passes all the way through the middle, That's called a diameter. And then a line that crosses over the circle, so it doesn't just stop on the circumference, that line is called a secant. Okay, so if ever you see any of these words, you know exactly what they mean. And then the other thing that's super important to remember is that parallel lines have equal gradients, and perpendicular lines, if you multiply their gradients, the answer will be -1. Okay, why is this important? Because a tangent is perpendicular to a radius, so you are more than likely going to need to use that bit of information there, because in grade 12 they like to test tangents. Let's take a look at one more example that comes from a past paper. It says here O is the center of the circle. Okay, O is also this origin here, just to bear in mind. P, X, Y down there, and Q, 12 and 5 lie on the circumference. So those 2 points, which makes this a diameter, all right, passing through the center. First question says, determine the equation of the circle. Okay, so on my formula sheet, I have got equation of circle. So I will go and look at that. Right, I need to have 3 things. 2 coordinates for my center, and then the length of the radius. Okay, center is going to be super easy, but sometimes I find students confuse the super easy ones. They try to complicate them. Okay, the coordinates of the center, they are just 0 and 0, so that really is going to be straightforward. But I need to then work out the radius. Okay, so let's work that out down here. According to our distance formula, it's x2 minus x1 squared and y2 minus y1 squared. And because both of those are subtracting 0, it's going to be quite easy. So 12 minus 0 squared plus 5 minus 0 squared, and that's all in a square root. Okay, type that all in on your calculator. Square root of 12 squared plus 5 squared, and we get a nice little neat answer there of 13. So now I can substitute into this equation, and I can say, well, my equation is x minus 0 squared plus y minus 0 squared is equal to r squared. Okay, so you can either write 13 squared or you can write 169. Okay, then question 2, determine the equation of the straight line. Let's pop question 2 in here to save space. Okay, equation of a straight line is y is equal to mx plus c. All right, so if we look at this, we can get the gradient, although I don't know this point. So, might be feeling a bit stressed, but not to worry. I've got this point here, so working out the gradient is going to be quite straightforward. So that's gradient for m, and then c is the y-intercept, and have a look there, we have the y-intercept. So not too much calculating to do. Let's work out the gradient. M is equal to y2 minus y1 over x2 minus x1. So the gradient is 5 over 12. And so therefore, nice and easy, the equation of this line, y is equal to 5 over 12x plus 0, which you wouldn't really have to write that plus 0 part there. So let's leave it at 5 over 12x. Now, determine the equation of the tangent, question 3. Okay, so what I said when we were looking at the terminology was that the tangent is always perpendicular to the diameter or the radius. Okay, that was one of our grade 11 theorems. So I can then say the gradient of PQ multiplied by the gradient of QR must equal -1. Okay, so I've worked out the gradient of PQ. That was 5 over 12 times the gradient of QR equals -1. So now the gradient of QR is equal to -12 over 5, if I work that out. Okay, so I've got the gradient of this line. Remember, it's a straight line. Tangent is always a straight line. Y equals mx plus c. So I'd still be aiming to work out the gradient and the y-intercept. Okay, so we've got that gradient now. Now we'll go back to our equation and we'll say, let's just follow it up here. Y is equal to -12 over 5x plus c. And then we need to substitute in a point on this line. Okay, and so this one here is a point that we have in its entirety. So let's substitute in the place of x a 12 and in the place of y, a 5. So we'll have 12 is equal to minus 12 over 5 times 5 plus c. And that, if we work that out, 12 is equal to, this 5 and this 5 will cancel. So that's just going to be minus 12 plus c. Move that negative 12 across, so we get c on its own. We'll end up with 24. So therefore, the equation of this tangent, y, is equal to minus 12 over 5x plus 24. See? Not bad at all, as long as we understand the basic concept. How to get the equation of a circle, what to fill in the place of a, b, and r, and then understanding that a tangent is perpendicular to the diameter. Remember that little bit of information, and you'll be able to solve any analytical problem that comes your way.